Karnaugh map. Okay, so that particular method actually we are using to minimize the Boolean expression and all those things. Okay, so now the defined minimization technique is called a Queen exclusive minimization method. Generally, what is the difference this particular method to the earlier method? Earlier method means what? KMF method. So KMF means what? There are some particular restrictions are there. Method is very well. Okay. So, exactly what is the difference this particular two method? Okay. So difference is that when we are using the KMF, so you know already 4 variables, it is okay. 5 variables, okay. When we are using the 5 variables with the help of KMF, then also sometimes what happen, the complexity is coming. But more than 5 variables, what happen, the KMF method is very difficult. Okay. So what happen? So there another method we are using the it is called a Queen exclusive minimization method. And this method there is a no restriction regarding the variables. Okay, we can use 6 variables, we can use 7 variables. Okay, and but this particular method is very simple and hand-on competition is required. Also, system we can write the code and program, and we can implement this particular method on computer also. Okay, so in the lab class also you can implement this type of Queen exclusive method. Okay, so most probably next week your lab class will be started. Now we are after this particular class we are entering to the combinational circuit. Okay. So today we are going to discuss lecture 17. We are going to discuss about this particular method. This particular method means what? Queen exclusive minimization method. So what is Queen exclusive minimization method? The Queen exclusive method also known as a tabular method. Okay. It is also known as a tabular method. So sometimes what happen, it is called a Queen exclusive method, sometimes it is called a tabular method. Okay, and this particular method is more systematic method of minimizing expression of a even large number of variables. So variable is the large number of variables. That time what happen, KMF have some problem. That means complexity is coming. It is not like it is not solving, but it is very complex. But what happen if we are using this particular Queen exclusive method, we can use for a large variable also. Okay, there is no problem. And this is suitable for hand competition. Okay, so generally when we are solving this particular problem, hand competition also with the help of hand competition also we can solve this particular problem. Okay, and as well as competition by machine also. Okay, so this logic minimization technique of some particular characteristics are there. The first one is what? It should be capability of handling large number of variables. So already we are discussing, and it should not depend on the ability of human user for recognizing prime implicant. So what happen when we are designing the KMF and all those things? That time what happen, we can find out all the groups. After that we are checking which particular cell is prime implicant, which particular cell is essential prime implicant. So a lot of complexities are coming. But what happen when we are using this particular method? That time what happen, it is not depend on the user or designer. It is automatically, if your process is correct, then automatically we can know which one is the prime implicant. That is the advantage of this particular method. Okay, and obviously this means this particular method we are using for minimization purpose. So what happens, so minimizing expression, whatever expression we are getting, that particular expression is a minimized expression. Okay, and it is also obviously what happen when we are using the it is handling, it is what it is just a minute, it is hand competition. Okay, this one is the hand competition. If we are using the hand competition, that time what happen, also what happen, we can, based on this particular hand competition, we can write some particular algorithm, and that particular algorithm we can implement with the help of programming. Okay, so what happen, computer solution also it is possible. Okay, so this is the characteristics of this particular Queen exclusive minimization method. So how we can solve this particular Queen Max Lucy minimization method? Just I am taking one particular example. You can carefully, I am discussing this particular example. If any doubt, then please ask me, don't hesitate. Otherwise, what happen? If doubt is there, then in future also you will be faced problem. Okay. So what happen here? Function is there. F, A, B. How many variables we are using? This particular function we are using only 4 variables, and we are using the notation means what? Mean this is the notation of mean terms, and numbers are there. Okay. And now what happen? If these particular numbers are there, that time what happen? We are using the Queen Max exclusive. Though we are using the 4 variables, it is also easy for KMF. But what happen when we are using 5 variables, 6 variables? Just for example purpose, I am using the 4 variables. You can use 5 variables also. You can use 6 variables also in this particular method. Okay. But problem is that in this particular method is very lengthy and time consuming. That is the main problem. Okay. Otherwise, what happen? We can handle any large number of variables. So what happen? How we can apply the Queen Max Lucy method in this particular example? So what happen? At first, we can design one particular table. Suppose this particular table name as a table 1. So what happen? Table 1 is prepared based on the grouping of mean terms, and how we can group the mean terms according to the logic value of 1. So see here, suppose here in this first part group index, we are writing the group number 0, 1, 2, and 3. And see second column, there is a mean term. Okay, mean term means what? Whatever the mean terms are present here. These particular all are mean terms. So it is 0. So see here, when we are writing the mean term in the binary format, so whatever it is 4 variables came up. So here I am writing 4 variables A, B, C, D. This is the 4 variable, the 4 variables method. Okay. So when we are writing the 0, so whatever how many digits I am writing? 4 variables. So we here it is 0, 0, 0, 0. And after that, what happened? Second group, I'm using 1, 2, 8. And why I'm using 1, 2, 8? Because when we are writing 1 in the binary form, there is only 1. Only 1 is present. Logic value 1 is present. When we are converting 2 in the binary format, then only 1 is present. And when we are presenting 8 in the binary form, then also only 1 logic value is present. So here it is also 1, 0, 0, 1. Here also it is 1. How many ones are occurred? 1. How many ones are occurred? So here only 1 is occurred. Here also only 1 is occurred. So what happened? This particular mean term forming a one particular group. So same thing, 3, 5, 9. When we are writing in the binary sequence of 3, that time here only 2 ones are occurred. And when we are writing 5, there also this one is 1 and this one is only 2 ones are occurred. And when we are writing 9, and this one is 1 and this one is 1. Okay, so 2 ones are. So 3, 5, 9 making a one particular group. Okay, so where we are getting? According to the question here, 3, 5, 9s are present. This one is 3, this one is 5, and this one is 9. Are you getting my point? So next one is what? How many mean terms are remaining left? 7, 11, and 14. When we are writing 7, that time 3 ones are occurred. Here also, when we are writing 11, here also 3 ones are occurred. Okay. So here 14 also 3 ones are occurred. So this is also we are making a one particular group. Now what happened? This particular last column, and whatever we are filling this particular symbol is coming later. Okay. So table 1 is already completed. Now what happened when we are constructing the table 1? That time this particular part don't write. This particular part is unknown for us right now. Okay. Now what happened next? When we are going to the table 2. Okay. So table 2 means what? Yes.
Sir,
Yes.
13 also.
Pardon?
Sir, it should be 13 also because 1011. 1101, sir.
Which one?
So in the last group index 3, we should
Uh-huh.
also include number 13.
13 is
Along
not
with
present. Nah. 13 is not present in the question.
Okay,
Nah. You can see.
okay.
Sir,
Yes.
sir, 2 is also not present in the question, but in the group index 1 we have 2.
Or maybe some there, I don't know. Just a minute. 0, 1, 2. Okay, then you can insert. Just a minute. Now it is okay.
Yes, sir.
Now it is okay. So here
Yes,
2
sir.
is present. Okay. So now what when table 1 is already completed. Okay, but remember last column we cannot why I am using this particular tick mark, and see here last row I am using one particular variable a. So you don't confuse, this one is coming in later part. Okay. So next what happen when table 1 is completed, we are going to the table 2. See here, now what happen, table 2 means what? Table 2 is created. Just a minute. Table 2 is created by comparing and matching. The mean terms in the adjacent groups of table 1. So this particular table 2 is actually from with the help of or using with the help of table 1. Okay, so table 2 is directly related to in table 1. Okay, so see here how we are grouping. Again we are making the group 0, 1. And what is this one? So I will explain you. See here, when we are, you know the distance of two binary codes. If distance is 1, okay, that time what happen, or distance is 1, at first we are comparing where the distance is 1. Okay, so what happens, see here, when we are comparing group 0 to group 1, again group 0 to group 2, again group 0 to group 3, again group 1 to group 2, again group 1 to group 3, again group 2 to group 3. Okay, we are comparing each group with each other. So what happened here, first group is 0, so 0 we are comparing with 1. Can I consider this one? Yes, because 0, 1 we can compare, because see here, this one is 0, 0, 0, both are same. This one is 0, 0, both are same. This one is 0, 0, both are same. But this one, 0, 1, last bit, that means LSB bit, see here, the first one is 0 and second one is 1. There is only one difference. So one times it is 0 and one time is 1. So only one difference. So what happened? Here I am writing dash. It is identified by dash. Okay. And which particular position it is occurred? 2 to the power 0. 2 to the power 0 means what? It is the difference is 1. How we are getting 2 to the power, you know 2 to the power 0 means what? 2 to the power 0 means this is the weight. Weight of dash means what? The weight of 2 to the power 0. Again this one is 2 to the power 1. Again this one is 2 to the power square. Again this one 2 to the power cube. So 2 to the power 0 means what? 2 to the power 0 means 1. So what happened? Here I am writing, for that particular purpose I am writing here 1. Again what happened? 0, 2. So 0, 2, see here 0, 2 is possible. 0, 2. So this one is 0, 0, 0, yes, both are 0, only this particular 2 bits are different. These particular 2 bits are different. So what happened when 2 bits are different? That time what happened? Here I am using dash. And which particular weight is considering 2? So same thing 0, 8, 0, 8. So 0, 8 means what? 0, 8 we are considering this one. So 0, is see all are 0, but the most significant bit is 1 and first one is 0. So that means what? The 2 to the power cube means what? 8 position is, we are getting the difference between the two binary sequence. So here I am writing this. Are you getting my point? So here I am writing here 8. This one is 8. Okay. So when 0, 1, 0, 2, 0, 8, when all the groups are considering, that time what when 0 already compared with 1. So here I am just ticking tick mark. 1 is already compared, so it is just tick. 2 is already compared, just it is tick. And 8 is compared, just we can mark as a tick, just for remembering purpose. That means which particular groups already we are comparing. Okay. Next, what happened? Next, we can compare 0, 2, 0, 2, 0, 3. So 0, 3, we can check 0, this one is all are 0 and this one. Here see, two difference are occurred. So it is not possible. 0, 3 is not possible. So here I am not writing 0, 3 because two bit positions are different. We need only one difference. So 0, 3 is not possible. Okay. After that 0, 5, 0, 5, see 0, 1, 0, again 1. Here also two bits are different. So we cannot consider 0, 5. Again 0, 9, 0, 9, this one is 0, 1, first MSB bit and the LSB bit also 0, 1. So two bit positions are different. So we cannot consider 0, 9. So 0, 3, 0, 5, 0, 9. Here it is not present. Okay. But when we are comparing 1, 3, 1, 3, see 1, 3 means what? This one is 0, 0, this one is 0, 0, this one is 0, 1. Yes, this one is 1. Only one bit is different. So which particular bit? So here, this particular bit. This means what? It is 2. 2 to the power 1 means what? It is 2. Again 1, 5. Again 1, 5. 1, 5. Which one is the 1, 5? This one. You can see here, this one is 0, 0, this one is 0, 1, this one is 0, 0. Only one bit is different. So this way we can make this particular table. Okay, you can consider 3, 7. 3, 7. See here 3, 7. If you are comparing, this one is 0, 0. Okay, no problem. This one is 0, 1. Yes, one bit is different. But this one is 1 and this one is also 1. Are you getting my point? So what when only this particular bit position is different. For that particular purpose, what happened? 3, C, what? This particular part is this. And this one is what? 2 to the power 0, 2 to the power 1, 2 to the power square means what? It is 4. Position is we are getting the difference. Okay. This way we can construct a table. Any doubt this one?
No, sir.
Any doubt this one?
No, sir.
Okay. But remember one thing, why I am writing here A? That is the main. Because see, if any group, if we are comparing with 14, that time what happened? 14 is not possible. 7 we are getting, 11 we are getting, 3 we are getting, 5 we are getting, 9 we are getting. Okay, no problem, 1, 2. But when we are comparing 1, 14, the more than one difference is there. Suppose what happened? It is the 0, 0. And whatever the remaining mean terms, if you are comparing with the 14, that time what happened? We are getting more than one difference. So what happened here? 14 we cannot tick here. So which particular part we are taking, which are already compared with each other. But one thing you remember, 14 we cannot compare with the other ones. Why? Because it is created more than two difference. That time what happened? We are assigning as a. And why we are assigning as a? Because you cannot use here P, Q, R, S. Because what happened in the according to the question, only 4 variables you are using. So what happened at first? What happened? 14 is we are not grouping any particular mean terms. So what happened? We are assigning as a here A. This one is what? A. And this particular part you can write in table 1, not table 2.
Sir.
Yes.
Sir, is this A the A of the variable of the function?
A is a variable which is belongs to the function f according to the question. Here it is already mentioned, na? This one is A.
Yes, sir. Yes, sir. No, not that. For the 14th midterm, we marked as A. What is
Yes.
that A, sir? Is that of the function only?
Yes. This particular A belongs to the function. This what function means what? We are using some particular variables, and
Yes,
based on that particular variables, we are creating the expression. Yes or no? No.
Yes.
Yes or no?
Yes, sir.
So this
Yes,
particular A is nothing but it is the variable of this particular function. That's all.
Okay.
Okay. So table one, we are how we are creating the table two, from the table one. And at first, what happened? This particular table one, how we can construct based on the how many ones are present. Okay. Uh, for that, we can creating many type of groups, or you can say index also. Some particular books it is mentioned index, and some particular book is group. So it is meaning is same. But remember, this one is mean term, this one is variable, and suppose here I am using 5 variables. Suppose A, B, C, D, comma E. That time what happened here? You are writing here E. A, B, C, D, E. But according to the question here, only we are using 4 variables. So for that particular purpose, we are using only A, B, C, and D. Okay. Now this particular table is already created. Again, what happened? Now what happened? Our comparison is not completed. Okay. So this particular process is going on. For loop. Okay. For loop is going on, and this particular table we are creating up to what? When the no comparison is possible. But till now we don't know that means comparison possible or not. How can we know? So what happened from the table two, we sure that the comparison is till now it is not completed. So based on the table two, we are creating table three. Okay. Now what happened? When we are comparing 0, 1, suppose again the same procedure we are applying 0, 1, 1, 3. See here, this one is 0, this one is 0, but this one is difference and this one is difference. So we cannot consider 0, 1, 3. Are getting my point? Now what is the next? 0, 1, 2, 3. Suppose again if you are considering, you can consider anyone. 0, 1, again you can consider 0, 1, 1, 5. See here, this one is same, 0, 0. But this one is difference. Again, this one is same. But again, this one is difference. So it is not possible. We cannot group 0, 1, 5. Okay. But if we are considering 0, 1, 2, 3, 0, 1, 2, 3, is it possible? See here, this one is 0. Yes, okay. This one is 0. This one is yes. This one is only, we are getting one difference. And this one, dash also same. So there is only one difference. So what happens? 0, 1, 2, 3 is possible. So when we are writing 0, 1, 2, 3, here see, here we are writing 0, 1, 2, 3. And which particular positions are, we are getting the difference. This one is what? 2 to the power 0 means 1. So here this one is 1. And 2 to the power 1 means what? It is 2. So here I am writing 1, comma. Okay. After that, again you see 0, 1, 8, 9. If you are comparing 0, 1, 0, 0, 1, 8, 9, that time see this 0, 0, 0, 1. It is difference, but this one is same. This one is same, and this one is also same. There's this. So what happens? 0, 1, 8, 9 is also possible. So here I am writing 0, 1, 8, 9. And which particular bit positions are difference? This one. 2 to the power 3 means what? 8, and 2 to the power 0 means 1. So here within bracket I am writing 1, comma 8. Same thing. Again compare. So 1, 3, 3, 7. 1, 3, 3, 7 is not possible because this one is 0. First bit is I'm reading from the MSB. First bit is 0, but second bit is difference 0 and dash. Third bit also dash and 1. So last bit, okay, last bit, that means it is more than one difference. So we cannot group 1, 3, 7. So this way we can continue. But what happens when we are comparing it 1, comma 3 with the 5, comma 7? That time you say, see, 1, 3, this one is 0. This one is 1. Yes, we are getting one difference. Okay, and this one is this. It is also same, and this one is also same. Yes, it is possible. So 1, 3, comma 5, 7 is possible. So here I am writing 1, 3, 5, 7. Which particular bit positions are difference? This is 2 to the power 1, 2, and this one is 2 to the power square means 4. Here I'm writing the weight. Whatever the number is generated from the weight, I'm writing within bracket 2, 4. Again, you can check 1, 3, 9, 11. You can check from the table 2, 1, 3, 9, 11. Which one is the 1, 3? This one is the 1, 3. And this one is the 9, 11. Now you can compare with the bit sequence. This one is 0, 0. The first MSB bit is different. The second MSB bit is same. Third MSB bit is also same. And fourth, the last LSB, that means it is 1, 1. So only one difference is possible. So here I'm writing 1, 3, 9, 11. So 0, 1, 2, 3. 0, 1. So this one is already compared. 0, 1, 2, 3. 2, 3. Which one is the 2, 3? This one is the 2, 3. But remember one thing. 1 is present here. Okay. This particular one also present here. So this is also we can compare. Are you getting my point? So 0, 1. So first one 0, 1, 2, 3. 2, 3 also there. Where is the 2 is present? This one is 2 is present. So we can, and 3, which one is 3? This one also 3. Okay, so we can tick all that this one. Next, see here 0, 1, 8, 9. 0, 0, 1, 0, 1. This one is also 0. 0, 1, 8, 9. 8 also present here. 0 also present here. So it is tick. And where is the 9? 9 also we can tick. 0, 1, 8, 9. And here also 1 is present. Here also 9 is present. So what happened? This one we can tick, and this one also we can tick. Because why we are ticking this one? Because this particular one is already we can compare. Because after all, what happened? 0, 1, 0, 2, 0, 8, 1, 3, all are what? All are mean terms. Okay. So next, see here 3, 5, 7. So 7 is already here. It is 3 also present, 7 also present. So we can already compare. So we can tick. Okay. And see here 3, 7, 1, 5. And 1, 5 is what? This one is the 5 and 7 also present. So we can tick here. Okay. And this one is already tick. Now, yes. Now what happened? Next is what? 1, 3, 9, 11. 1, 3, 9, 11 means what? This one is the 9, 11. So we can tick. And here also 3 is present. So we can already tick. Here also 3 is present. So we can already tick. So what happened? All the mean terms we can compare with each other. So we cannot assign any particular variable. Like the last table here, it is 14. So 14 we cannot compare. So here I'm writing here, instead of tick mark, I'm writing the variable. But in this case, what happened? All the mean terms are compared with each other. So here I'm writing all the tick marks. Any doubt this one?
No, sir.
No, sir.
Now what happened? From the table 2 here, when we are creating table 3, from the table 2, that time what happened? We are getting this one. So what happened? Here it is this, here it is this. So we are writing all the this. Now see, when we are again, we are going to construct the table 4 from the table 3. So table 4 means what? We can compare this one with this one, this one with this one. But is it possible? See here, if we are comparing 0, 1, 2, 3 with 1, 3, 5, 7, that time what happens? See here, this one is 0. Yes, okay. But this one is 1 difference. This one is same. But this one is also difference. So it is more than 1 difference. So 0, 1, 2, 3, and again 5, 7, we cannot compare. Again, you can check 0, 1, 2, 3 with the second group 1, 3, 9, 11. Is it possible? It is also not possible because first one is 0 dash, second one is dash dash, but third one also similar. But fourth one, that means most LSB is 1 and dash and 1. So it is different. So 2 difference we are getting. So what happened? We cannot compare with 0, 1, 2, 3 with the 1, 3, 9, 11. Next, again, what happened? You can consider 0, 1, 8, 9 with the 1, 3, 5, 7. Also, it is not possible. 0, 1, 8, 9 with 1, 3, 9, 11. Then also it is not possible. Why it is not possible? Not possible because we are getting more than 1 difference. So what happened? We cannot tick here. So what happened? We can assigning as a B, C, D, and here E. Are you getting my point? So whatever, which particular groups we are not, which particular binary sequence we are not comparing. It is not possible to compare. So this one is not possible to compare. So we are assigning as a B. Why I'm writing B? Because already in table 1, we are assigning as a A. So after that, whatever, this one is B. And next one is, this one is C. Next one is D1 is D. And fourth one is E. Oh, okay. Hello.
Yes, sir.
Someone is asking me. Someone is asking me this particular A. Okay, this particular A is not directly related with the function. This just we are assigning the variable. You can write any numbers, P, Q, something like that.
Yes, sir. That only I asked.
Oh, okay. Now I'm getting. Okay. So this one is what? Just your, but it is better. You can, whatever the variables we are assigning, you can use this one. Okay. So whatever, because whatever many particular, suppose 8 groups are there. Suppose here 8 groups are there. Maybe there are many groups, they are not matching with each other. So whatever our number of variables, we are increasing more. So that particular increasing number, just we are assigning that particular binary sequence. So it is not directly related to, sorry, that particular function. Okay, it is good. Now I'm thinking. Okay. ये ना क्लास रिप्रेजेंटेटिव है क्या? क्लास रिप्रेजेंटेटिव? Class representative is present or not?
No, sir.
Now what happened? Now you cannot create any other table, because what happened? From the table 3 we know that there is no matching is possible, no comparison is possible. That time what happened? Your for loop operation is stopped. That means what? When you are writing the hand competition, that time what happened? No need to construct any table. So in this particular question, table, how many tables we are creating? Table 1, table 2, and table 3. We cannot create table 4. So how we can know table 4 is not created? Because when all the min terms of that particular binary sequence are not matching with each other, that time what happens? We can stop it. Are you getting my point? Now easily we can find out we can write the expression. How we can write the expression? See here, you can find out the variable, initial variable, where the initial variable is started. In table 1 means what? This one is A. So A is related to which binary sequence? 1, 1, 1, 0. Because what happened, according to the question, this one is the min term. Generally, we are using the min term. We are not using the max term when we are using the Queen-Maxwell-Lucy method. If it is max term, then we can convert to the min terms. Because what happened, it is easy for us to doing the min terms. Okay. So 1, 1 means what? 1 is related with A, 1 is related with B, and C is related with 1. And 0 also assigning with D. So A, B, C, 1 means what? Uncomplement A, B, C, and 0 means what? Complement in min terms. So what expression, what terms we are getting? A, B, C, and D bar. So here I am writing A, B, C, and D bar. Next one is what? B. B means what? Only C and D we don't know. It is 0 or 1. But we know A is 0 and B is 0. So here I am writing A bar and B bar. After C, we are getting 0 and 0, and A and D we don't know. C. So we are writing here B bar, C bar. So this one is the B bar, C bar. D is what? A is A bar, and 1 means what? D. So here I am writing A bar, D. And this one E, here this one is B, B bar, and this one is D means what? 1. So here I am writing B bar D. So this is the expression. Now, someone is asking from this particular expression, you find out the prime implicance. Okay, so see here, if we are finding the prime implicants, that time what happen? This one is called a PI table. That means prime implicant table. Are you getting my point? So prime implicant table means what? Prime implicant table means we can, the last class we know what is the definition of prime implicant. But here what happened? How we can say which one is the prime implicant and which one are the essential prime implicant. Okay. For checking purpose, we are using this particular prime implicant table. So how we can construct this particular table? So at first, what happened? From the expression, we are writing all the terms here. In first column, we are writing all the terms. And this, how many terms are there? This one is A, B, C, D bar, one term, A bar, B bar, C, A bar, D, B bar, D. So we can write one by one in the first column. Second column, what happened? A, B, C, D bar, it is coming from which particular mean term? 14. So here I am writing here 14. Okay, A bar B is coming, this particular A bar B is coming from 0, 1, 2, 3. So here I am writing 0, 1, 2, 3. Okay, and next one is what? C is coming 0, 1, 8, 9. So this one is 0, 1, 8, 9. Next, D is coming 1, 3, 5, 7. So this one is 1, 3, 5, 7. Okay, and E is coming 1, 3, 9, 11. So here I am writing 1, 3, 9, 11. Getting my point? After that, what happened? All the mean terms, I am writing the third column. Third column is what? Mean term. See here, don't use the round at first. Just you can, some particular symbol we are using, that is called a cross symbol. And how we can assign the cross symbol? See here, A, B, C, D are related only 14. So just we are marking as a 14. Just we can cross as a 14. Okay, next one, the second mean term A bar B bar. It is A bar B bar is related to which particular decimal number? Decimal number means what? It is the which type of mean term, the number we are using. Okay, 0, 1, 2, 3. So here we can, 0 is cross, this one is cross, this one is 1, this one is cross, 2 is cross, 3 is cross. Next one is what? 0, 1, 8, 9. So 0 is cross, this one is cross, 1 is cross, 8 is cross, okay, and 9 is cross. 1, 3, 5, 7, 1 is cross, 3 is cross, 5 is cross, and 7 is cross. Then last term is what? 1, 9, 3, 11. So 1 is cross, 3 is cross, 9 is cross, 11 is cross. Now, when we are assigning all the cross corresponding to the decimal numbers, after that, see how we can check. We can check each particular, we can consider all the mean terms and corresponding rows. Suppose what happens if we are considering 14, any particular cross are there? No. When no cross are there, just we can round this one. See here in column number 11, so numbering, that means what? It is maybe 11. So see here, no cross are there, so we can round this one. But we cannot round in column number 9 because here also it is cross and here also it is cross. Two cross symbols are there, so it is not possible. But 8, see here, only one particular cross are there, so we can round this one. 7 also we can round this one. 5 also we can round this one. Okay, but we cannot round column number 3 because here also cross is present, here also present, and here also present. Okay, now, oh sorry, this one is some mistake. Actually I am doing some mistake. Don't use this one is the cross. Okay, because here we cannot use the round symbol here because already 3 cross symbols are there. So instead of this one is the cross, round symbol. This one is not, huh? don't consider the column number 1. It is, we cannot consider the round symbol. And first in the column 0, that means what? We cannot create a round symbol. Okay, because here also cross is there and here also cross is there. Now see, cross is there in the prime mean term A, B, any cross, any round symbol is there with cross. Any round symbol is there in A, B, C, D term? Yes, because in A, B, C, D, this one is the cross symbol, round cross symbol. And what about the A bar, B bar? A bar, B bar also present one particular round symbol with cross this one. What about B bar C? Yes, B bar C also one particular cross symbol in column number 8, this one. And what about the A bar D? A bar D also there are two particular round symbols are there. Okay, but B bar and D, yes, B bar D also one particular cross symbol is there. Round with cross symbol is there. So that means what? B bar, D bar also prime implicant, essential prime implicant. This one is also essential prime implicant. This one is also essential prime implicant. All the terms are prime implicant of this particular example. So what happened here? I am writing therefore all the EPI means what? Essential prime implicant. It means what? This one also EPI. This one also EPI. This one is also EPI. And these all are EPI, and obviously what happened? All terms are PI, prime implicant. Okay, and this is the minimized expression. This way we can complete this particular Quinn-Max-Clusi method. Any doubt? Now, if you are not getting, then please ask me. Don't hesitate.
Sir, sir, that A, B, C, D dash, it is not included in any prime implicant, no, sir.
Which one?
First one, A, B, C, D dash. It is not included in any prime implicant.
Not implicant with the prime implicant means what? I'm not getting.
Not in, sir, you told that all these have a essential prime implicant. But also they are all included in the prime implicants. But the prime implicants only contains the largest group of ones or cross or zeros. So, sir, the first one is not included in any prime implicant.
Yes, this one is ABCD bar. When we are talking ABCD bar, because see here, when we are ABCD bar, in C0 also yes, there is no cross symbol, only one particular cross symbol is there. Okay?
Yes, sir. Yes, sir.
For that particular purpose, what happened? This one you cannot avoid ABCD bar. Okay. Yes, sir, yes, and also what happened? It is the large group. So obviously what happened? ABCD bar is a EPI.
Yes, sir.
But what happened? Now, if you are asking me the PI, you can check. See here. This one is this. If it is EPI, then obviously what happened? The inherent characteristics of PI is present. Are you getting
yes,
my
sir,
point?
yes, sir. Yes, sir.
So that is why what happened? All the EPI. That means obviously what happened? All the EPIs are there. So obviously what happened? All the terms must be satisfied the PI. PI
yes,
means
sir.
what? Prime implicant.
Prime implicant.
Okay.
Yes, sir.
And generally what happened? Remember one thing. When we are using this, because what happens? See, don't compare directly with the KMS when you are finding the EPI.
Okay.
What I mean to say that what I want to say that when you are using the Quinn-Max-Clusi method, that time what happens?
Yes, sir.
Because this particular table we are constructing for what? For what means what? Suppose see, okay, see, when we are computing the EPI and PI in KMF, that time what happened? You can making all the possible groups. After that, check one by one group that particular rules are satisfied or not. Rule means what? The rule belongs to which rules belongs to the PI and which particular rules belongs to the EPI. So what happened?
Yes.
is totally depend to the designer or user. Okay, if something is wrong, that time automatically the things are wrong. But when we are using the Queen-Max method, this particular table especially we are using for to finding the EPI and PI. Okay, and when we are writing
Yes,
this
sir.
particular table, whatever the terms we are using, all the terms must be a PI, and this particular part we are getting from the what? We are getting from the table. Are you getting my point?
Yes, sir.
So when,
Yes, sir.
so when we are making the constructing the table, and so name is table name is PI. That means what? PI means what? Prime implicant. So by default, all the terms are prime implicant. All the terms are what? Prime implicant. Now, from this particular table, main task is that which one is the EPI? That is the main task. So what happened here? See, all the terms against cross symbols are present. That means what? All are
Essential
what? All
prime
are
implicant.
essential prime implicant.
Yes, sir.
See here, you can write this particular true example on your copy. All of you write this particular example on your copy. बाद में मुझे मत बोलना का सर ये क्या हुआ, ये आप लोग एग्जांपल, सॉरी, दिस इज द एग्जांपल 1 एंड सेकंड वन इज एग्जांपल 2. हो गया? लिखना हो गया?
Yes, sir.
Now tell me the first question, example 1, the question is correct or wrong? You tell me.
Sir, wrong.
Why?
Sir, it is having 21, 24, 25, and this.
Now it is okay? No.
We have having function A, B, C, D, E.
Now it is okay? Now it is okay?
Yes, sir. Yes, sir. Now it is okay.
Yes, sir.
So what happened? Up to 31 means what? There are 2 to the power 5 means what?
2 to the
32.
power 5. Yes, sir.
So if we are using only 4 variables, then it is not solvable. So from the mean terms, automatically you understand how many variables are there. But second one is, see, only 4 variables, but it is okay because we are going not more. We are not going 16. We are not going beyond than 15. Okay. So here, what happened? Example 2, we are using only 4 variables. See, the first example I am not discussing because what happened? It is same as it is the whatever we are discussing earlier. Earlier example we are using 4 variable, but here we are using 5 variable. So it is your duty to complete this particular example in your home. Okay, this is your task. The example do something is some differences there because what happened here? D means what? Here I am using don't care. But till now we are not discussing how to handle don't care with the help of this particular Queen-Max method. Okay, so just I am giving one particular concept, and after that you will try at your example 1 and example 2. So if don't care term or don't care mean terms are there, that time how we can solve with the help of Queen-Max method. You see, all are same. Remember, suppose 0, this particular 0 is suppose don't care mean term. That time you can use just per in superscript you just use the star. Star means what? For remembering purpose, which particular mean terms are don't care and which particular mean terms are not a don't care. Okay. Other parts are remaining same. All the parts are remaining same. And why this particular symbol is required? Because what happens when you are constructing the PI table, you can automatically understand that this particular 0 is star means what? 0 is belongs to the don't care. Okay. And all other comparing parts all are same. Here also suppose I'm using 3. So 3 is don't care, then I'm using here 3 superscript 3 star. So that means what? Automatically we know that 3 is belongs to don't care. But remember, main difference is that this particular comparison part and the tick mark and all those things are as it is, them remain same. But this is also same. Okay. But problem is that when you are constructing the PI table, always remember when you are writing 0, 1, 2, 3, that time what happen? Please don't use the don't care term here. Suppose 0 is don't care, then you delete this particular 0 from this particular table. If 1 is not don't care, then yes, you can put here. Are you getting my point? And after that, whatever same competition you can do. This particular table also similar. But one thing always remember, when some mean terms are belongs to the don't care, that time what happen, that particular mean term don't include in this particular PI table. And other parts are remaining same. And when we are constructing the table, you just denote some particular special symbol star as a subscript, and automatically we know that yes, this particular 0 is belongs to the don't care. हो गया? ये कर पाएंगे आप लोग? कर पाएंगे आप लोग?
Yes, sir.
When your second internal exam?
21.
21.
Very good. Today is 13. ठीक. And as soon as after 2 and 4 days, you will get the instruction sheet. Okay. I'm giving WhatsApp group, and you can find out what is the syllabus, what type of questions are coming, what is the template of that particular question. Okay, everything you will find out. Okay. Okay. $9.59. So today, from the lecture 18, we are directly going to the combination circuit. Parallelly, you can check your syllabus also. What? Okay. So sometimes what happen, maybe some particular things we are discussing earlier and some particular thing we are, but we can follow the unit wise. Okay, no problem. So this particular lecture 18, we are discussing about the combinational circuit. Especially, we discussing how to construct the combinational circuit. Construct means what? How to design the combinational circuit. And this particular part is very important for you. Okay. And till now, whatever we are discussing, that particular knowledge or that particular concept we are using when we are designing the combinational circuit. Okay. So up to lecture 1 to lecture 17, it is very much important for us to build the basic knowledge, and that particular knowledge we are considering when we are designing the combinational circuit. And now what happened, you are getting different type of same, the concept is same, but the sentence is something different, but logic is same. Okay. Now what happened, what is the combinational circuit? So you can read this particular point and you can automatically understand what I mean to say actually. Okay. And what is combinational circuit exactly? So combinational circuit means what? Whatever the outputs are produced from that particular circuit, always remember that particular output totally depend on the present input. That is the main characteristics or main point of this particular combinational circuit. Whatever the output produce, this particular output totally depend on the present input. If present input is something changed, automatically it is reflected out. Okay, so it is not like that minutes ago I'm using some particular input and whatever the outputs are generated, I will keep for a long time and for the different inputs. No, that is not possible in conventional circuit. That means what? Output always depend on the present input. If present input is changed, then automatically output also change. And always remember, in conventional circuit, whatever we are discussing the earlier, it is many number of inputs or output may be one or more than one. So it is not like that output always produce only one particular output. It is maybe more than one output. Okay. So different type of examples we are using, suppose substructure, adders, this is all are the conventional circuit. Multiplexer, demultiplexer also belongs to the conventional circuit. Decoder, encoder also it is conventional circuit. Comparator also it is. I am giving some example. It is not like that these particular three circuits are only conventional circuit and there are no other circuit. It is not like that. Now I'm not using except this one. Some examples I am providing. Like suppose comparator. Comparator also one type of conventional circuit. Okay. And after that, what happen? If we will get some particular concept or logic, say yes, this one is this one, this one is this one, and now you can your own concept. You can design your own conventional circuit. Okay. And after that, what happen? Based on that particular logic, which particular gate is suitable of that particular function, you can decide. Someone is using some defined gate, someone is using universal gate, someone is using basic gate. Okay. And from that particular concept, you can create the Boolean expression. After that, you can minimize the expression, and when you are getting the minimized expression, directly you can design the conventional circuit. And from the expression also, then how you can check that this particular circuit is correct or not. So from the expression also, you can design you can construct the truth table. Truth table means what? Behavior of that particular circuit. And you can cross verification also. It is possible. Okay. So means what? If I am designing this way, sorry. This one is two inputs are there. This one is one input is there. So output is produced, and this particular output is totally depend on the two inputs. Okay, this is the behavior. This is the you can check the different type of block diagrams are there in conventional circuit. Okay, but this particular input we are not using any feedback part of the input. This particular output we are not connected with the input. So if it is connected, that time what happen? Our conventional circuit is wrong. So that means what? This one is the output. I am talking about the output. Yes. Feedback and some particular fan out, this type of things are included in the conventional circuit. But whatever when the outputs are generated, this particular output, there is no connectivity with the input. If there is connectivity, then we cannot assume that this one is the conventional circuit. So what happened? Here, the last sentence I am writing, in this circuit, there is no concept of memory. So after a few classes, we are discussing some sequential circuit. That is something different. Then that time what happened? Memory concept is coming. But when we are talking about the conventional circuit, always remember there is no memory concept. Suppose what happened? Now we are going to design our first combinational circuit as a half adder. So half adder means what? You can just read this particular definition. A half adder arithmetic circuit have two binary bits. So always remember, when we are using the half adder, we are using only two binary bits. That's why this particular circuit also called a two binary adder. Sorry. Sometimes half adder also called a two binary adder circuit. So that means what? This particular half adder only we are using only 2-bit addition, not more than 2 bits. And when we are designing this particular circuit, how many inputs are required and how many outputs are required? Yeah, obviously we are using the 2 bits means what? 2 inputs we are using and 2 outputs we are using. One output is called a sum and another we are called a carry. And how we are generating the sum and carry bit? According to the rules of normal binary addition. So you know, the previous classes we are discussing what is binary addition, what is binary subtraction. Okay, all part we are discussing. Now what happen? You can apply that particular concept. Okay. Suppose just a minute. Yes. Suppose how we can draw the truth table of half adder. This one is the input. Inputs. And this one is the output. Okay. So suppose I'm using input AB and this one is the sum and carry. So 2-bit, if we are using the 2-bit, 2 to the power square means what? How many? 4. So 0, 1, 0, 1. Okay, 0. So when we are adding 2-bit 0, 0, that time what happened? What is the output? Sum also 0, carry also 0. So this one is 0 and this one is 0. When we are adding 0 plus 1, that time what happens? Sum is 1 and carry is 0. When we are using 1, 0, that time what happens? Sum is 1 and carry is 0. And when we are using 1, 1, that time what happens? Sum is 0 and carry is what? Carry is what?
1.
Carry is what? 1. Yes. Now, can you, from this particular table, you can write the expression of S and C. From this particular truth table, can you write the expression of S and C? What is the expression of S? बोलिए अभी तो आपको मालूम हो जाना चाहिए एक्सप्रेशन क्या होगा What is the expression of sum? What is the expression of carry? क्या हुआ ठीक Anjali Chaudhary. Are you hear me? Anjali Chaudhary. Oh, that means you are not in the class. Okay, I am giving as a absent to you. Okay. Ankur Kumar Giri. Ankur Kumar
Yes,
Giri.
sir. Yes, sir.
Okay, then what is the expression of S?
Sir, expression. Can I see that again, sir?
ये आपको क्या when I am when you are on the screen that time you are not keep with your ये pen and ये copy.
Sir, yes, yes, sir. Yes, sir. I make notes every day, sir. But sir, after the class, because sir, if I make notes during the class, then I won't be able to understand, sir.
Okay, this is up to you how you can handle. It is not my concern.
Yes,
it is
sir.
up to you. Okay.
Yes, sir. Yes.
So this is the
Yes.
table. Okay. This is
Yes.
the table.
Yes, sir.
And this particular table, I am considering this one is the table, and from the table you can find out what is the expression of S and what is the expression of C.
Yes, sir.
Only you can tell what is the expression of S.
Sir, A dash B plus A B dash.
This is the expression of S.
S. Yes, sir.
Okay. Okay, stop. आप कुछ मत बोलिएगा.
Okay, sir.
Bikiran Setia. Bikiran Setia.
Yes, sir.
What is the expression of C?
A B.
Hmm?
A B.
AB. Okay. So the earlier answer also correct. Now your Setia's answer also correct. Both are correct. Okay. So S is A bar, A B bar plus A bar B. Okay. And C value is AB. It is good. Rahul Ray. राहुल रे मतलब इन लोगों ने क्या किया ऑन करके जस्ट एडमिट हुआ है मीटिंग में और वो वहां पे प्रेजेंट नहीं है. वेरी गुड. ओके. राजू कुमार.
Yes, sir.
ओके. स्विच ऑफ योर माइक्रोफोन. संघमित्रा देवरी. संघमित्रा देवरी. वो भी लगाकर छोड़ के चला गया. ओके. वेरी गुड. शिवम ग्वाला.
Yes, sir.
ओके. तपास रॉय.
Yes, sir.
तमालिका रॉय. Tamalika Roy. I know this particular name very well. Okay. Arnav Paik.
Hello.
Yes, sir.
Arnav Paik. Okay.
Yeah, yes, sir.
Jatin Burma.
Yes, sir.
Hello, sir.
तमालिका रॉय, मैं आपको एक बार बोल चुका हूँ और उसके बाद आप
Sir,
बीच में
no, sir. Your voice was not audible. Like, I knew that when you were calling Tapish Roy, I knew that you were going to call my name.
No, I don't know. I'm not asking the ये explanation. To the point बात कीजिए आप. जो मैं पूछ रहा हूँ वही बात कीजिए. Okay,
Sir,
okay,
your
that is
voice
enough.
was not audible.
Okay, that is not that is enough. Okay. So what is the S? S is A. S is A. S is A. A, okay, A B bar plus what? Plus A bar B plus A bar B. Okay, and A B bar plus A bar B means what? We can write this way also. A XOR B. A XOR B. We can write this way also. Because A XOR B equal to A B bar plus A bar B. And C value is A B. Okay, C value is A B. So when we are getting this particular S and C, that means this particular two expressions are already minimized from. Okay, we cannot minimize further. So then directly you can design the circuit. So how we can design the circuit? So just you can use this one, okay, this one, and this one. This one is what? It is S, and this one is A, and this one is B. And after that, what happened? From here, we are using here, and from here, we are using this. And AB, C means AB means what? We can use the AND gate. And this one is what? It is C. Okay, and this particular symbol means what? This particular symbol is XOR symbol. This one is the XOR symbol. So S is A XOR B and C equal to A. Now, if I am just, you can try this one. A half adder can also realize in universal logic by using either only NAND gate or only NOR gate. Just you tell me, if we are using the NAND gate, what is the value of, what is the expression of S and what is the expression of C? Suppose I am interested to design the half adder with the help of NAND gate, this particular NAND gate, okay, then what is the expression of S and what is the expression of C? Can you tell me? Just you can do this one. Put कीजिए इसको. If you are using NAND gate, then how we can construct the circuit of half adder? And when we are designing the circuit, you can use only NAND gate. No other gates are allowed. No other gates are allowed. And same thing you can use for NOR gate also. That means what? Your expression means what? You can create the expression such that when we are converting that particular expression to the circuit, that time what happen? All the circuit must be a NAND gates only or NOR gates only. सब क्यों दाम पूरा साइलेंट? Why you are keeping silent? जल्दी कीजिए, बोलिए क्या है? S का और C का भी.
सर
हाँ बोलिए.
सर एस का वैल्यू 1 हो जाएगा क्या?
ये कैसे 1 होगा? ना
नहीं सर, मतलब ए भी चेंज हो रहा है, बी भी चेंज हो रहा है सर.
अरे you can create the expression such that when you are constructing the half adder, that time what happen? You can use only NAND gates. That is our objective. 1 होगा, 0 होगा, उससे कोई मतलब नहीं. ठीक है?
ओके.
हम लोग जब सर्किट हम लोग डिजाइन करेंगे सिर्फ NAND गेट ही होना चाहिए उसमें. तो उस टाइप से हम लोग को एक्सप्रेशन को कन्वर्ट करना पड़ेगा. समझ में नहीं आपको क्या इक्वेशन में लिख रहा है? वो सामने पॉइंट क्या है? ठीक से पढ़िए पॉइंट को.
ठीक है सर.
Sir, S is equals to A B bar plus A bar B.
देखिए मैं आप लोग अपने पास रखिए, मैं धीरे धीरे कर रहा हूँ, आप लोग भी करते रहिए और देखिए इसके साथ क्या हो रहा है। तो मेरा भी ये एक्सप्रेशन सिर्फ ऐसा नहीं है कि इट इज द फिक्स answer only fixed. The different type of answer is coming from that particular expression. Okay, but your main objective is that from that particular expression you can design the circuit such that all the gates are NAND gate. Okay, so this one is the AB bar, and this one is the A bar B. A bar B. Okay, next one. Can we write this particular expression something like that? A B, A bar B bar plus A bar plus A1 नीलूदा हाँ हाँ नहीं नहीं एमटेक का तो नहीं निकला है अभी तक। ठीक है ठीक नहीं निकला है नहीं निकला है। हाँ हाँ बस we can write this way also. After that whatever we can write this way. A bar plus B bar. Okay. Plus B A bar plus now it is okay, you can check. Now it is okay or not?
Yes, sir.
So
Yes,
now
sir.
from this particular two expression, you can easily draw the only NAND gate. I am not draw the circuit. You can draw yourself. And after that, ये क्या करना पड़ेगा आप लोगों को एक assignment. This is the actual assignment. Okay, so you can realize the half adder using only NAND gates, or you can using the half adder only using NOR gates. That means you realize the half adder using only NOR gates or NAND gates. ये पूरा पूरी आप लोग एक्सप्रेशन लिखिएगा S का C का, and this particular expression is not fixed, you can design your own way also. Okay, आप क्या कीजिएगा, उसके बाद you can draw the circuit. Okay, you can draw the circuit based on this particular expression, but remember, when you are designing the circuit, that means that time only NAND gates are appeared, must be appeared, no other gates are allowed. And if you are designing with NOR gates, then only NOR gates are appeared in that particular circuit, no other gates are allowed. तो ये मुझे क्या करना है, आप लोग को पीडीएफ में आप लोग पीपीटी भी बना सकते हैं, पीडीएफ भी बना सकते हैं, नहीं कॉपी में लिखकर आप लोग फोटो भी मार के मुझे स्क्रीन में दिखा सकते हैं. सो नेक्स्ट क्लास में क्या करूंगा, मैं किसी को नहीं बोलूंगा, फट से मैं किसी का नाम बोलूंगा कि भैया XYZ आप बोलिए, आपका सर्किट नैंड गेट का वो दिखाइए, तो सबके पास रहना पड़ेगा. रैंडमली मैं किसी को भी पूछ सकता हूँ. और क्वीन एक्सक्लूसिव का जो दिया था उसका भी आप लोग कॉपी में फोटो मार के यहाँ पे प्रेजेंट नाउ करके, प्रेजेंट नाउ मैं नहीं करूंगा, आप लोग कीजिएगा. मैं जिसको बोलूंगा वो प्रेजेंट नाउ ऑप्शन का क्लिक करेगा, ऑन कीजिएगा, एक्टिव कीजिएगा और वो अपना असाइनमेंट शो कीजिएगा. ठीक है, समझ में आया? समझ में आया कि नहीं आया?
Yes, sir.
आप लोग बहुत मजा ले रहा है, मैं ही क्लास में बोल के जा रहा हूँ, आप लोग सो रहे हैं कि क्या कर रहे हैं भगवान जाने. सो नेक्स्ट क्लास में रेडी रहिएगा कि मैं किसी को भी पूछ सकता हूँ. क्या क्या पूछ सकता हूँ, ये वाला जो आपके स्क्रीन के सामने जो क्वेश्चन है, नैंड गेट का भी पूछ सकता हूँ, नॉर गेट का भी मतलब पूछ सकता हूँ. आप लोग वो फोल्डर स्क्रीन में खोल के रेडी करके रखिएगा. हाँ, मैं बनाया नहीं हूँ, वो नहीं होगा. एंड आई विल अरेंज द मार्क according, and also you can complete the queen exclusive also. और इस क्लास के बाद मैं क्या करूंगा, मैं किसी को भी कुछ भी पूछ सकता हूँ. सो बी प्रिपेयर. ऐसा नहीं है कि एक्टिव करके घर का काम कर रहा है, मोबाइल वहां पे मैं बोल के जा रहा हूँ, आप लोग आराम कर रहे हैं, कोई दूसरा काम में बिजी है. अभी ये पता चल जाए कि आप लोग ऑन द स्पॉट उस पोजीशन पे है कि नहीं. ठीक है, नेक्स्ट क्लास यू विल रेडी फॉर दैट. ओके. Okay, then after that you can try this one and NAND gate and NOR gate. After that we are going to the half full adder and different type of things are there. Suppose this type of things are there, you can design your circuit. And how can you design? Okay, when suppose one person is entering the room, that time light is on, and when is out from the room, then light is off. Or different type of logic I will prepare and you can design the circuit. Okay, so you cannot directly design the circuit. Before that, you can write the expression, write the function, and you can elaborate the function with the help of Boolean expression. After that, you can simplify that particular function with a minimize form. And which particular technique you are using, either you can use the normal exams rules or KMF, or it is more than 5-6 variable, then you can use this particular queen explicit method. When you are getting the minimize expression, then you can design the circuit. And when you are designing the circuit, your circuit must be a combination circuit. Okay. So ये सब कुछ आपको खुद करना पड़ेगा, मैं भी यहाँ पे डिस्कस करूंगा, वो करके वो होगा. And after that we are going about the multiplexer, demultiplexer, encoder, decoder, comparator. Okay. And different type of adders types are there. Subtractor, parallel adder, binary, parallel adder, 3-bit adder, different type of subtractor are also there. So we will discuss. So it is required hardly 8 or 9 classes are required. Okay. Then combination circuit is over. Then we can go to the threshold gates. Some type of concepts are there. Threshold gate, that particular part we will discuss. Okay. Leave one by one.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.